Hi everyone, today we are going to talk to you about ethylene oxide production process. First of all, let's understand what is ethylene oxide. So, first things first, ethylene oxide is one of the most exceptional heterocyclic in the chemical industry. Why? Because it's unique ring structure. As you can see here, this is oxygen-carbon bonds. They are so weak. Because of that, this chemical is so reactive. It can undergo a variety of reactions like isomerizations, polymerizations, and types of things. And these properties, these are so important. Why? For example, boiling point, we will talk about it in separation part. Its boiling point will help us to separate it, and also flammability limit. It will say something about its conversion rate, and we can move on. Ethylene oxide, as I said, it is so reactive. Because of that, it can be used in variety of industries, but mainly they use 72% of the usage of ethylene oxide is ethylene glycol. Ethylene glycol, it's so familiar to us. Why? It is in the production of antifreeze we use in automobile industry. So let's talk about the situation in the world. Mainly we have three players in the industry. America, actually, America, they produce a lot, but they don't export, so they use they themselves. For Europe, for example, Germany is the major player in the industry. They produce approximately 55%. They export. They use and also they export the ethylene oxide because of automobile industry, I think. So Asia, we can see Asia. Asia is in the every industry. They are so huge. Like in here, ethylene oxide, they control the 50% of the industry. So in Turkey, unfortunately, we have just one factory, which is Petchem in Izmir. They just produce the same amount of every year, and our need increased, and our production is still same. So gap is increasing day by day. So when we come to the process selection, actually, historically we have three process selection, but as you can see in this graph, this is the production capacities in United States. In 1980s, the chlorohydrin method is already phased out. So we have the discussion continues with direct oxidation, but how with air-based or oxygen-based. So I don't want to go deep dive into that, but we have high selectivity in oxygen-based, and also we don't have so much purge. We don't have so much purge, and also in air-based we will need more equipment. So because of that, because of this selectivity, ethylene is so expensive. We produce. We choose the ethylene oxygen-based production. So we choose the process selection, we choose the method, but how we get oxygen? We can get oxygen by buying, or we can produce it. So we make a gross profit analysis, and we can see that if we buy it, this is our money that we get, and if we produce it, we have advantage. So actually, we didn't want to indicate the region, but the capacity is so much related to the location. Because of that, we evaluated, and we have so much reason, but we don't want to go deep into that. Our production capacity is 250. Production capacity is 250 kilogram per kilogram ton. So for our we have just 30 ton per hour. When it comes to the work diagram, actually the production process, the idea is simple, but we have lots of equipment. Basically, we have four main sections. In in the first section we have feed preparation. As we said, we produce oxygen. We don't buy it. So this is the oxygen getting. So and this part we have the other reactants. And second section is the reaction section. And after that we have two sections. Our conversion is 20%. That means we have 80% reactants, which is not going any reaction. So we will take them back. So this is ethylene recovery section, and the 20% of them we are producing it purely.
So I will keep going with the process flow diagram. We start from the first section. We feed the air to a multi-stage compressor system to attain the pressure needed for the distillation tower, which is 5.7 bar, and then we heat exchange it with the product stream, which are cold streams, to recover some heat and to attain minus 177 Celsius. Here it is saturated stream. Then when it enters the distillation, the more volatile component, which is nitrogen, it will go to the upper stream, most of it, and the bottom stream will have nitrogen, but it will be rich with oxygen. Then we feed it to the next distillation column, which operates at a lower pressure, so more nitrogen can go to the upper stream, and we will get oxygen with a purity of 0.99. Here also the energy balances are shown. So after that, our oxygen, which is our raw material, will be fed to a multi-stage compression system. It will be compressed to 25 bar, which is our operating condition. Also, we will feed the ethylene and methane and the recycled stream, all of them at the same pressure to 25 to the mixers, and their values are here. In the reactor section, we will heat exchange it with the product stream to recover some heat, and then the hot utility will do the rest to attain 240 Celsius, which is the reaction for the which is the reaction temperature. Our reaction is isothermal because our selectivity it depends on temperature, so we have to control the temperature. And also our conversion per pass is 0.20. It is solo because we want to prevent the second reaction, which is the five-product reaction, since increasing the conversion will decrease the selectivity. Also, our reaction is highly exothermic, so it will emit this heat, which must be removed to maintain the isothermal condition. Then the effluent from the reactor will go to the absorber. Since its mass fraction is so low, we will first absorb it with water, since ethylene oxide is highly soluble with water, and it will go for the downstream. The upstream, which contain ethylene and other raw material, will go to the CO2 absorber to remove the CO2 generated by the byproduct reaction by potassium carbonate solution, and the upstream will go to the recycle again. Then we have this CO2 stripping column, which will recover for us the potassium carbonate solution again to the absorber, and up we will have CO2 vent. In the bottom section,
water solve the ethylene oxide and take it from the bottom. So we can move on to the strippers. And strippers, the reverse idea is consistent in here. We have, for example, in the first stripper, for example, in T104, we take the carbon dioxide that we get by absorber, we take it, we purge carbon dioxide, and for T105, it was as you might remember, it was in the purification of ethylene oxide. So we take back ethylene oxide. In here, we take back ethylene oxide as a vapor site. So we choose for absorber, we choose valve type tray because of the high pressures. But in here, stripper, we choose for the first one we choose sieve trays, and the second one it is again the high pressure, 6 bar. Actually, it's relatively high pressure, and we again use valve tray because of this pressure amount. So when it comes to distillation, first distillation, this is in the purification of ethylene oxide. In here, why we choose sieve tray? Actually, ethylene oxide is so reactive, and we don't want to see any local hot plug. Because of that, we choose sieve tray, and its pressure is not so much. Because of that, we don't want to use it valve tray, and it is also expensive. We have huge amount of production capacities. Because of that, we choose economically and also sieve tray. You can see the specification here. And the first two distillations, they are working on cryogenic conditions. What does it mean? It operates at so low temperatures. So because of that, in the first one, we choose valve tray because of the high pressure. The second one is again sieve tray, and you can see the specification here.
Some of this.
You can see the McCabe drawing. So, as you can see, we have so much heat exchangers because our conditions are so varying. In the beginning, cryogenic. At the end, it is so high. So, because of that, we need to operate these conditions. We have 10 heat exchangers. You can see they are shell and tube to increase the surface area and other things. Compressor, also we have 6 compressors to operate the conditions. You can see the blade type, and also this is centrifugal compressor. We choose it according to the mass fraction. And also lastly, pumps. We have just 2 pumps. Why we have 2 pumps? Because our process in the gas phase mainly, we have just in ethylene recovery and ethylene oxide purification, we have just liquid phase in there. Other than that, we have just gas phase. We have 2 pumps. They are multi-stage pumps. So this whole our presentation. Thank you for listening.